Welcome back to Calculus. For our third video, we're going to be talking about trigonometric functions. Now, most review of trigonometric functions, especially when you're reviewing it in pre-calculus, it starts talking about angles and radians and the right triangle definition. I'm going to skip all of that because, again, I'm assuming you've taken pre-calculus or know enough pre-calculus at least to start learning calculus, because pre-calculus is an absolute requirement for calculus. That's why it's called pre-calculus. Anyway. I'm just going to start by talking to you about the different functions. So we have sine, we have cosine, we have tangent, and then we have their inverse functions. They also have reciprocals. There are three other trigonometric functions, but for the purposes of this review video, I won't be covering those. It's more in detail in pre-calculus. Now let's talk about sine. How does sine look like? Well, it looks a bit like a wave. In fact, it is a wave function. It's a periodic function, meaning that it repeats the same segment over and over again. And that would be this segment right here. It repeats this over and over again to infinity. It oscillates between 1 as the maximum and -1 as the minimum. And it starts technically at 0, 0. Although it doesn't really have a starting point, the origin is sort of like the locator point of it, so it's 0, 0. How does cosine look? Well, cosine is very, very similar to sine. It actually can be obtained by sine when you translate it a bit. So it has the same exact shape, except its locator point is 0, 1, the maximum, instead of the origin. And again, same shape, same periodicity. So it's nothing too exciting, but tangent looks nothing like these two functions. Tangent, it has asymptotes, kind of like a rational function. If I were just to make a rough sketch, it would look a bit like this. It sort of looks like a cubic function to some people, but it doesn't really have much to do with the cubic function. It just sort of looks that way. And you'll notice, like I said, it has asymptotes, unlike sine and cosine. This also has a period. It repeats this big segment, the cubic function looking segment, over and over again. Now, I talked about their inverse functions. They each have an inverse function that's pretty important in pre-calculus and calculus, so I'll just graph them for you. Like with an inverse function, it has a little -1 at the top. That does not mean an exponent. It does not mean 1 over sine, because that's what an exponent of -1 usually means. But it's not an exponent. It just is an indicator that it's the inverse of sine. So how do we find the inverse of sine? Last video, we talked about one-to-one functions and why that's a requirement for inverse functions. This is why. When you have a function like sine that looks like this, you'll notice that it's not one-to-one because each output has more than one input. When you draw a horizontal line, there's literally intersecting at infinity points. So how can we solve this? Well, we can take just a small portion of this. I'll color it in red. If we take this segment right here, that is one-to-one, and in fact, it's the maximum we can take while still being a one-to-one function. So the inverse of this would look like this. You'll take that and you'll get the inverse, which looks like this. And we can't really extend it, but if we were to, it'll look something like this. That wouldn't be a function, so we can't really extend it, which is why sine or inverse sine is only defined on this domain right here. Moving on to inverse cosine. As you might imagine, it looks very similar to inverse sine. Since cosine is like this, inverse cosine we'll have to take a different segment this time. We'll take from here to here. And the inverse graph would look like this. That's sort of how inverse cosine as a function would look like. Remember, you can extend it, but it won't become a function, so we can't really do that right here. And it would be defined on this domain, the inverse sine. Well, technically, it's the range of the inverse sine. It's the domain of the sine that you take away. Similar with cosine, like I just showed you. And our final one, tangent, it's probably the least exciting of them, because you don't have to split it up into like at definite points. Since it has asymptotes, we'll just take the portion between any two asymptotes. So I'll just draw that right here, and we'll just take this portion. There's really no use drawing the rest of it right now. So if we take this and we invert it, we get the inverse tangent, and it looks something like this. And it has these horizontal asymptotes. Before they were vertical, now they're horizontal because, remember, we're inverting it. And those are basically the inverse trigonometric functions. In calculus, you would have to use inverse trigonometric functions a lot, and honestly, they behave a lot differently than normal trigonometric functions, so good luck with that, I guess. And next video, we're going to be talking about exponential and logarithmic functions. And we're also going to be talking a bit about hyperbolic functions, which you might not have heard about in pre-calculus, so it'll actually be a pretty thorough introduction on that. So that is it for today's video, and I'll see you next time.